everyone, welcome back to JNJ.dev. I'm Jin3x and today I'll be explaining a highly efficient solution for the 2583rd problem on LeetCode, kth largest sum in a binary tree with a medium difficulty using JavaScript. Before we jump into the solution, I'd like to mention some prerequisites which will be good to have, but you can understand the algorithm we're about to write even without them. They include binary tree and breadth first search. If you're not familiar with that data structure in this search algorithm, there will be links to blogs down below that explain them. Okay, let us get started. Something we must always do is read the problem and understand it properly. From the description on LeetCode, we see that we are given the root of a binary tree and a positive integer k. Next, we are told about a level sum, which in this problem is the sum of all nodes on each tree level, otherwise known as depth in the tree. From the first example we are given, level sum of level 0 would be 5, then its children will give us the level sum of level 1, 8 plus 9 in this case. This can be done for the other levels as well. Next, we are told what we are to return, the kth largest level sum in the tree, without the need for them to be distinct. We also note that if the tree does not have more or equal to k levels, we are to return -1. Now we are given two examples, which can further help us explain how the algorithm should work. You can pause the video to look at them more closely. At the bottom of the problem, we are given its constraints. We are told that the number of nodes in the tree is n. Then we are shown that we have a minimum of 2 nodes and a maximum of 10 power of 5 nodes, which, if I didn't hit my head with a brick while calculating, will be a total of 100,000 nodes. The possible values of each node will be between 1 and 1 million. The k variable can be anywhere within the n range, so between 2 and 100,000. The algorithm we will write is rather simple once understood. The general idea is to traverse through the tree, and the sum of the nodes at each level will be saved to an array. Once we have traversed the whole tree, we will sort the sums array and return the kth largest sum. For traversing, we'll use the BFS algorithm with a small trick to optimize for speed. First, we will define a variable with the name of q, and its first element will be the root parameter that we are given. Next, we define a constant called level sums, which is an empty array. This will be the array that contains the sums of each level of the tree. Now, we write a while loop, where the loop will continue until the queue is exhausted. As we'll see in a bit, after each iteration, the queue will be refilled with the children of the current level, which will allow us to keep on using the while loop until all children are traversed. We'll define a next queue variable, which will be an array. This is where we will store the next level's nodes and replace the original queue variable in a bit. Before that, we also define a variable current sum, which will hold the sum of the current level. Next, we create a for loop where we iterate through all nodes in the queue variable, where, simply said, are all the nodes of the current level. We define a current node element that represents the current node with which we are working. Then we add the current node's value to the current sum. Lastly, we check whether the current node has left and or right child. If it does, then they are added to the next queue variable because they represent the nodes of the next level. Once we have exited the for loop, we push the current sum to the level sums and we replace the queue variable's value with the next queue's one. That way, on the next while iteration, we will begin the whole process from above with the next level of the tree. Once we have exhausted all levels of the tree, we go to the last part of our algorithm. Here we check if there were enough level sums to cover for the kth element. Remember that each level sum represents one level in the tree. If the length is not enough, we return -1 as requested in the description. Lastly, we sort the level sums in descending order and return k-1 sum because arrays are 0 indexed. Now we test our algorithm to see whether it passes the first tests. It passes, so we now submit it to all tests and see how we do. And just like that, we have solved this problem with a runtime that beats 84% and memory that beats 66% of all other solutions. Thank you for watching this video. If you enjoyed it and want to see more LeetCode problems explained like this one, please leave a comment and subscribe. Have a great day!